Okay, section 3.7 is on multiplying polynomials. We've done a little bit of multiplying polynomials in the previous sections with multiplying binomials, and basically that was based on the distributive property, which we summarized to the method of FOIL, F for first, O for outside, I for inside, and L for last. Now we're going to extend that those properties to multiplying binomials by trinomials, and sometimes trinomials by trinomials, but we can't call it FOIL anymore because there's more steps involved. But it is basically the distributive property, and that's what FOIL is based on. So the first example, we have 2x times x squared. That's going to give you 2x cubed, and you don't have to keep drawing these arrows in. I'm just drawing them to help you see what I'm doing. So 2x times 4x is going to give you 8x squared. And then the 2x gets multiplied by the negative 5, which is going to give you minus 10x. And then we move to the 3 and distribute the 3. So the 3 gets multiplied by the x squared, the 3x squared. 3 gets multiplied by the 4x for 12x. And the 3 gets multiplied by the negative 5 for minus 15. And then we just put the like terms together. So we've got 2x cubed. We've got plus 11x squared, and we've got a negative 10x and a 12x, so that combines to give you a 2x, and then we've got the minus 15 is the only constant there. And so if we just do the next one now, is again a binomial by a trinomial. We've got 4x times 4x is 16x squared, and then 4x times the negative y is minus 4xy, and then the 4x times the 2 is plus 8x. And then the next term in the binomial has to be distributed, so that's going to give you negative 3y by 4x is negative 12xy, and then negative 3y by the negative y is going to give you plus 3y squared. And then the negative 3y gets multiplied by the 2, which is minus 6y. And then I would probably put these in the order, because you got x squared terms and y squared terms, and combination xy terms as well as x and y individual terms. I would probably start off with the x squared term, and then I would probably go to the x term, and then I'd go to the combined xy term, which is, there's two terms there with the combined xy, that would be minus 16xy, and then kind of work down to the y squared term, so that would be then the y term, or work up to the y squared term if you want, which is, and then the last term is 3y squared. So if you look at the first two examples that we did there, we had two terms distributed across 3, and in the very first step of both of those products, we had 6 terms. 2 across 3 terms, 2 times 3 gave you a total of 6 in the first line. So if we're going to expand a trinomial times a trinomial, how many terms would you expect when you're distributing 3 terms across 3 terms? You would expect 3 times 3, or 9 terms. So let's just work out the last one here on the page. So we've got 2y squared times 5y squared is going to give me 10y to the 4. And then we've got 2y squared times 2y is 4y cubed. And then 2y squared times a negative 4 is negative 8y squared. And then we move to the negative y. Maybe I'll change the color just so you can see it a little bit better. So negative y times 5y is minus 5y cubed. And negative y times a 2y is minus 2y squared. And then negative y times the negative 4 is plus 4y. And I'll do the last one, the 3 gets distributed to the 5y squared, which is going to be 3 times 5 or 15 y squared, and then the 3 gets distributed to the 2y, which is going to be 6y, 3 times 2y, 6y, and 3 times last one, 3 times a negative 4 is going to give you minus 12. And again, you don't have to be drawing those arrows in. I'm just putting them there to help you see what I'm doing. So now if we put the like terms together, there's only one y to the 4 term. But there are 2 cubed terms, so 4y cubed and negative 5y cubed is negative y cubed. And there are 1, 2, 3 y squared terms. So that's, I'm just going to underline them twice. So that's negative 8, and negative 2 is negative 10, plus 15 is going to be positive 5 y squareds. And then you've got your 4y and your 6y is 10y. And then you got your minus 12. Okay, the next page are just basically just practices this procedure. So the first one would be 3x times 2x, 6x cubed. 3x times 3x is 9x squared. And then the 3x times the negative 4 would be minus 12x. And then of course you move to the 1. 1 times the 2x squared is going to be 2x squared. And 1 times the 3x is going to be 3x. And 1 times the negative 4 is going to be negative 4. So that's going to give you a 6x cubed term. And you have 9x squared and 2x squared for a total of 11x squareds. And a negative 2x and a 3x for negative 9x's. And then your minus 4. And the next one, 3a times 2a is 6a squared. 3a times 3b is 9ab. And 3a times the negative 1 is minus 3a. And then the b times the 2a. Now that's b times 2a, but I'm going to write it as 2ab rather than 2ba, just because I've already got a combined term ab over here and I want to keep them the same. So b times 2 times a is the same as 2 times a times b. And then the next one would be b times 3b, which is going to be plus 3b squared. And then you got the b times the negative 1, which is going to be minus b. I'm just going to put that in there for a minute. So then we've got a 6a squared term, and we've got a single term with just a, so that's minus 3a. And then we got a 9ab and a 2ab for a total of 11ab. Then I'm going to work my way up to the b squared term. So I've got a squared, a combined term, then minus b we had, and plus the b squared term. The next two are just a little bit longer because they're trinomial times a trinomial, and then the last one there has a couple of different ones you've got to multiply out and expand. So we'll try the trinomial times the trinomial first. So 5t squared times 2t squared is going to be 10t to the 4. And then the 5t squared times the 4t is going to be 20t cubed. And then the 5t squared times the last one is going to be minus 15t squared. And then you're going to distribute the negative 2t, so that's going to be negative 4t cubed. And then negative 8t squared. And then negative times the negative is going to give you a positive 6t. And then the 1 is going to get distributed. 1 times the 2t squared is going to be 2t squared. And 1 times the 4t is going to be 4t. And 1 times the negative 3 is going to be negative 3. And then if you put the like terms together, you have a 10t to the 4 term. You still need t to the 4 term. But you do have messy, I just gotta fix that. Okay, so then you have a 20t cubed and a negative 4t cubed term, so that's going to give you 16t cubed. And you have 3 t squared terms, negative 15t squared, a negative 8t squared, and a 2t squared. So that's going to give you negative 15 and negative 8 is negative 23 plus 2 is going to be negative 21 t squared. And then you have 6t and a 4t, which is 10t. Is that the same one that we did a few minutes ago? Some of the numbers are the same. Minus 3. Okay. Just going to move that up. And that's all the like terms put together then. Okay, so the last example here, you've got two things going on. You've got a group here and then add it to a second group. So we'll just do piece at a time. So the first one is two binomials, so it's going to be 12m squared. And then minus 8m. And then plus 3m. And then a minus 2. And then you got plus. Now, some people will probably distribute the 2 first. If you do that, you only distribute to the first brackets, because once it's part of that first brackets, it will then get distributed when you distribute those first brackets to the next term. But I usually just deal with I usually do this part first, the binomials first. So that would be 2m squared times 3m, 2m times 3m. Negative 3m is negative 6m squared. Right? And then the 2m times the 4 is going to be 8m. And then the minus 1 times the negative 3m is going to be positive 3m. And then the minus 1 times the 4 is going to be minus 4. And then you've got 12m squared. And you can put these two terms together as minus 5m minus 2. And I'm just going to hold off multiplying that 2 there. First I'm going to put these like terms together. So I've got negative 6m squared plus 11m minus 4. And again, some of you might be able to kind of combine the last step we just did with the step I'm going to do right now. But I'm just showing every step in the workings here for now so that you can see what I'm doing. So when I just did that there, I just realized that this positive 2 is going to get distributed to a negative 6m, so that's going to become a minus 12m squared. And then we get the positive 2 distributed to the 11m, so it's going to be plus 22m. And then 2 times the negative 4 is going to give you minus 8. So if you put the like terms together, the 12m squareds are going to cancel each other out actually. And you're going to have negative 5m and 22m is a positive 17m minus 10. Okay, so this next one is similar, except this time you have the trinomial in front, but you still use just distributive property. So it's 6h squared times 2h, which is 12h cubed, and then 6h squared times a negative 3, which is minus 18h squared. And then you move to the h, so the h times the 2h is going to be 2h squared. And then the h times negative 3 is going to be minus 3h. And then the minus 2 times the 2h is going to be minus 4h. And minus 2 times the minus 3 is going to be positive 6. And then we've got basically 4h minus 3 squared, so that's 4h minus 3 times 4h minus 3. A common mistake that people make here is they take that squared and square the 4h and square them and say 4h squared minus 3 squared, and that's not correct because you can only use that power rule of bringing the power inside to each term inside the brackets if there's only multiplication or division between the terms. You can't do it if there's addition or subtraction between the terms. So before I multiply out the 4h minus 3 by itself, I'm going to put the like terms together in my first multiplication that I did. So 12h cubed. It's the only cube term, but the two of these can come together as minus 16h squared. And the two of these can come together as minus 7h plus the 6. And I'm going to deal with this negative outside the brackets after. I'm going to keep brackets here because I want to subtract the product of 4h minus 3 by 4h minus 3, so I want to remember to distribute that negative after. So that becomes 16h squared, and I got 4h times 4h, and 4h times the negative 3 is going to be minus 12h, and then minus 12h, and then plus 9. And when you're multiplying binomial by itself, there is a little rule that you can use, and if you want to skip a step there, and it's basically when you have something of this type, a minus b or a plus b all squared, it'll always be, when you multiply it out, it'll be the square of the first term, it'll be, in this case, minus twice the product of the two terms, and then add on square of the last. And if this was a plus in between the a and b, the only thing that would change would be the middle term would be plus 2ab. So if you have this, that will, when you multiply it out, you'll always get the square of the first plus twice the product of the two and the square of the last. And you can see that that's what's going to happen when I write down. I'm just going to write this one down first, the first part first. But when I write this one down, I get 16h squared, I get minus 24h plus 9, which is the square, 16h squared is the square of 4h, 9 is the square of negative 3, and then minus twice the product of 4h and 3 is minus 24h. So that little rule works. Alright, so now I'm going to copy this down again. This time I'm going to distribute the minus throughout those three terms. So that's minus 16h squared minus times a minus is going to be plus 24h, and then minus times 9 is going to be minus 9. So that would be 12h cubed, and minus 32h squared, and minus 7 and 14 is going to be positive 17h, and then a 6 and negative 9 is going to be minus 3. Okay, so the last type of example you can have in this type of work is something like this, where you have to find the area of the shaded region. And basically what you have to do here is the area of the shaded region equals the area of the outside triangle or rectangle minus the area of the inside or smaller rectangle. So the area of the shade, in this case, the outside rectangle has dimensions of 6x plus 5 by x plus 3, and the inside rectangle has dimensions of 2x and x plus 2, and I'm going to put the 2x in the front. Doesn't matter which order, but I just like having this if it's a monomial times a binomial, I prefer to have the monomial in front. And then we just multiply this out and simplify. So 6x times the x is going to give you 6x squared plus the 18x plus the 5x plus the 15. And then you got minus, and I'm going to distribute that minus 2x to both of these terms. So it becomes minus 2x squared and minus 4x. And then all we have to do is put like terms together. So we got 6x squared and a minus 2x squared is going to give you 4x squared. 18x and 5x is going to give you 23x, and 23x minus the 4 is going to give you plus 19x. And then you got your positive 15 left over. And that's the simplified expression to represent the area of the shaded region. There's some examples on pages 186 to 187 that you can try in your textbook that will help you practice some of these types of skills.